It only takes one wire to control so many colored LEDs. We can achieve any effect we desire. In my previous understanding, to control an RGB LED light requires 3 wires, because there are 3 kinds of lamp beads in a LED lamp. How can that one wire control so many LED lights? The main reason for this is that it has tampered with the lamp. You can see the difference between it and regular LED. Conventional LEDs generally have 6 silver corners. This smart LED light has only 4 sound chambers. And in addition to the integrated lamp beads, inside this smart LED, there is also a WS2812 chip integrated. It has 24 latches inside. After we pass the information to the data input pin of this chip, these 24 bits of data are temporarily stored in the latch. This chip will be fully responsible for controlling the work of the lamp beads. That LED needs a thread. If it is 64 LEDs, don't you need 64 wires? In order to simplify line connection, WS2812 adopts the instant connection method. That is, the output of the previous device is connected to the input of the next device. Such a wire can control many LEDs. In traditional communication, high usually represents logic 1, a low level represents a logic 0. In the single bus communication protocol of WS2812, logic 1 is composed of a specific timing combination of high and low levels. The high level lasts for 800 nanoseconds. The low level lasts for 450 nanoseconds. Now, logical 0. It's 450 nanoseconds high. The low level is maintained for 800 nanoseconds, because the data period is 1.25 microseconds, so its communication frequency is 800 kHz. This is a frame of data controlling an LED light. 24 people in total. Each color requires 8-bit data control. And then finally, low levels of more than 50 microsecond. It represents the end of this frame. If you want to control 2 LEDs, you need to send 48 bits of data. When the first chip receives 24 bits of data, the latch on the first chip no longer receives data. The remaining 24 bits of data are sent to the next chip, and so on. You can connect more LED lights in series. If it is to control 6, you need to send 1,536 bits of data. The refresh rate at this time is about 508 Hz. That is, the pattern can be changed 508 times in 1 second. If it is to control 1024 LEDs, it needs to send 24,576 data. The refresh rate is about 32.5 Hz. The frequency of the video we usually watch is generally 30 Hz. At this time, the refresh rate is close to the control limit of WS2812, although it is theoretically possible to control an infinite number of LEDs. But when the number of series LEDs reaches about 1,000, it exhibits significant signal attenuation. Also, if 1,000 LEDs require a large amount of current, if an LED consumes a maximum current of 60 mA when it is completely white, when 1,000 LEDs are all white, it is 60 amps. At this point, signal integrity and power distribution issues need to be addressed. Except for WS2812, there is also a driver chip called WS2811. WS2811 is an independent external driver chip, separated from LED. Many outdoor LED light bars use the WS2811 scheme. You can see that there is a chip every few LE and D lamps. This is the polarity scheme of WS2811, compared to the 5-volt dry voltage of WS2812. WS2811 supports 12 or 24-volt dry voltage, and high voltage can effectively reduce the current. Therefore, the voltage loss in long-distance power supply is reduced. There is another very important point. WS2811. This chip external solution, even if a certain LED malfunctions, the 3 lamps in series will go out, but it does not affect the normal operation of other parts of the entire light strip. And WS2812, once a LED is damaged, it can cause problems along the entire signal chain. All subsequent lamp beads fail. Therefore, WS2811 is more suitable for large-scale installation and long-distance power supply reliability scenarios. And WS2812 is more suitable for small projects, such as DIY art installations, dynamic displays, etc. Okay, this is how a single bus smart LED works. Hope it helps you understand.